Welcome to all. Happy New Year. Now, question number 32. Locate centroid for the given lamina. Make a note. What is this? This is center here. This is a lamina where from a semicircle of diameter radius 100 millimeter, inside another semicircle of radius 75 mm is cut out. See, actually, see, it is like this. This is semicircle, 100 mm. This is existing semicircle. So what someone has done is, he removed a portion here. See, this much is removed. So, for this one, you have to locate centroid now. First of all, make a note. As usual, see, usual notes. First of all, see, rough sketch. This is this one. One more thing. Or, this in the question, they can give so many ways. Instead of giving 100 this radius and 75 this radius, make a note. They can give this radius 100 and this thickness 25. Okay, then this will be 100 minus 25. Or inner radius can be given 75, thickness 25, outer you can find 100. They are simple. Okay, now first make a note. This is the semicircle. Once again remember, usual statement. This is the real, see, this is the actual lamina. Here, this is axis of symmetry. Therefore, this distance and this distance directly, see, if this is 100, this is also 100, directly 100, 100. Or, therefore, x bar, no need of finding x bar, we need only y bar. We need only y bar. For that one, take reference axis through base. Now, one more statement regarding how to find it. Divide, you write here, divide the given lamina into two parts. Two parts, that is, both semicircles. Both semicircle. That is, one semicircle, see, this way, of radius equal to 100 mm. This way, radius equal to 100. This you call figure number 1. From this one, cut out. Imagine, see, this portion. This semicircle, see, this is full semicircle. This is cut out. This is cut out. Cut out of radius equal to 75. Make this note. Understood? Okay, now finally, okay, all this over. One more statement. I told only y bar required. Y bar, to get y bar, consider reference line or axis AB through base, AB at the bottom edge, AB through bottom edge, or as shown in figure. See, take baseline here. Okay, now this all over. Now statement. Therefore, remember now, see, now you should be very careful. This full semicircle is 1. How? Where I'll write it down? See, I will write somewhere here. Full is 1. I cannot show it here. See, 1. Empty is 2. Inner is 2. 1 is not this one. See, 1 is full. See, I'll show once again here if you want to understand. Not required. See. Of radius equal to 150, this is your 1, and of radius equal to 75, inner one, this is your 2. Okay, this statement you write. Once you write all the statement, Then usual statement, y bar formula, nothing to explain further now. Therefore, write y bar, write y bar from base AB equal to A1 Y1 minus A2 Y2 divided by total area. Total area is A1 minus A2. Now, when you do calculation, we do not want radius. I told I want diameter. So, for one, this full outer semicircle is partially rubbed out. Okay. Radius is 100. So, dia equal to 200. For the empty portion, 75. Radius is 75. Dia is 150. Therefore, y bar equals, see, now, for the entire semicircle, this full semicircle, centroid is here, G1. It is, see, 2d by 3 pi when d equal to 200, not 400. I first decided 400. I am changing to 200 now. D is 200. Okay, this is 150. 150, okay. For which, see, this is the centroid for this entire semicircle 1. Don't see here. 2d by 3 pi, d is 200. For the inner cutout portion, centroid G2 is this distance is, see, again 2d by 3 pi, but this time diameter is 150. So y bar equal to area of the full semicircle, pi by 8 of 200 square, pi by 8 diameter square into this distance y1, 2d by 3 pi, d is 200, minus area of the inner portion, empty portion, pi by 8 of 150 square into this distance is 2d by 3 pi, d equal to 150 divided by total area, pi by 8 of 200 square minus pi by 8 of 150 square, you will get 56.083 millimeter. Actually, the real number is 56.08317,042. I will tell you why I wrote it. Actually, third decimal sufficient, 56.083. Over. Now, do one thing, or one presentation, see, one small presentation here. Therefore, see here, therefore, centroid, that is G, for given lamina, is as shown below. See, 200, radius 200, that is 200, 175. Okay. Okay, this is sufficient. See, this is axis of symmetry. I told already. See, this is your given lamina. For this given lamina, centroid is from here to here is, both are, how much it is? 100, 100, 100, 100. And from the reference line AB, see, from base AB, from where you took y this way, your y bar is 56.083. Now see, this is 100, this is 75. Therefore, 56 means it will come somewhere here. This is 56. See, G, if I project somewhere here, this distance is your y bar equal to 56.083 millimeter. Those who want can do one thing, from total 100, subtract it and get from other side if you want. Suppose someone wants how much from the topmost edge, from 100 subtract 56.083, 43.917. Now, one important observation, those who are serious. If this inner portion is not cut out, that is, if it is full semicircle of diameter 100 mm, see, one more thing. For those who get confusion of this sketch, do one thing, you can do one thing, see, or make a note. You take one this way, a semicircle of diameter 200, and then minus, subtract one more semicircle of diameter 150. This is 2d by 3 pi, area pi by 4 200 square, 2d by 3 pi area pi by 8 of 150 square. You can make this note. Now, one important observation. If this cutout is not there, you make a note here. G1 distance will be 2 into 200 divided by 3 divided by shift pi. It is 42 point something. Now what happened is, since you are removing the area here, centroid will shift always that side, or whenever you remove some area, centroid will shift to that side where more area is there, or as you keep on removing area, centroid will keep on moving away and away from it. So instead of 42, it came 50, how much? 6.083. Now, for those who can understand, one extra observation. See, I'll do one thing now, one extra observation I'll give only for those who are interested in the concept. Next question is 33, I'll put later. Okay. None of them, this answer required. That's why I wrote the answer. See, right here. Long back, you can write once upon a time. Long back, we considered the bookwork, that is proof for locating centroid of semicircle. At that time, one sketch was written here. See, this way one sketch given. Radius was taken R. Radius was taken R. This was a semicircle. How we had, I told you, two options were there. One of the option was, option one was, you take a strip this way of thickness dy at y from here, then get the width b dash here equal to, it was, derivation was in terms of r. It was in terms of r. 2 root r square minus y square. That was the width of the strip, 2 top r square minus y square root 2. This was the formula we used there. And finally, we got y bar equal to 4r by 3 pi, where r is the full radius. Long back, see the class. Go back to see, in the beginning I have done derivation. I did first for a triangle. After triangle, I came for semicircle. At that time, two options are given. One option is this option. The second option, I told, see there, I am not explaining much now, is you consider a small elemental strip. Where is this? At a radial distance r from here, see small r, very important. This is capital R. A elemental strip, I told very small, of arc length ds, thickness dr at angle theta. And the angle, see, first of all, I told there, the angle made at center here, neat sketch was there. This angle was d theta, this variation is theta. This is radial length r, see. There, we got y bar you require, is numerator by denominator. Numerator was integration of dA into y. Denominator is area. Okay, consider that numerator. Numerator, that is integration of dA into y. That is, finally I wrote integration, after simplifying all, one variation is theta, other variation is r. I don't know which one I wrote first, anyone. If I wrote r variation, 1 minute, ds equal to r d theta, ds equal to r d theta, r d theta into dr, into height is r sin theta. Okay, it came r square into sin theta into dr. Actually, I will write here into dr and d theta. It came that way. Limit is one integration is 0 to r, other is 0 to pi. This was what we wrote there. You see there. I won't explain. It was very thoroughly explained. Why? Because, see, that I told you. This strip, we want to cover full radial wise. From here to here, everywhere you want to come. So, 0 to r. And we want it to cover the entire, from here, complete up to here. That is 0 to 0 to pi. Because 0 at pi radians. But and then finally you got some answer. But now, suppose you apply same principle here, then what happens is here. Here, your semicircle is like this. This is the existing one. This is removed. So, this capital R is now 200. No, not 200. 100. And the empty portion is 75. So, or see, that is from, see, we can make once again here. From here to here is 75. 75. From here to here is 100. Correct? Correct, 175. Okay. Therefore, that formula will now change over to integration not 0 to r. We want only from here to here. So, it is 75 to 100. So, your r variation will not be 0. A small r variation is not 0 to 100. 0 to 100 will give you full semicircle. We want only here to here. And angular integration is correct. Integration 0 to pi of r square sin theta into d theta. If you solve this one, you will get the answer. See, into d theta into dr. This all I won't explain, dr. If you do r square dr integration, it becomes r cube by 3. It is 100 cube by 3 minus 75 cube divided by 3. 100 cube divided by 3. So it will come 100 cube divided by 3 minus 75 cube by 3, and integration of sin theta d theta is minus cos theta. 0 to 2 pi is cos pi is minus 1 and cos 0 is 1. Minus 1 is minus 2. Minus cos theta will become 2 into 2. The answer will be, this is the numerator then. And denominator is area. Area equal total area. In terms of radius, it is pi into 100 square by 2 minus pi into 75 square by 2. Because by not in terms of diameter, in terms of radius. Circle is pi r square, semicircle is pi r square by 2. Now if you operate your calculator, 100 cube minus 75 cube divided by 3 into 2 divided by bracket pi by 2 of bracket 100 square minus 75 square equal to 56.08317.042. I am not seeing there. Now slowly I will lift my head and see the answer there. Oh, yes. Only for those who are interested. See, this is called the beauty of mathematics. See, I will tell frankly with you, honestly, I never came prepared for this calculation because this I can make out. ds equal to r d theta, area equal to ds into dr, and then variation is 0 to r and 0 to pi. I can see all these things. I never came. Directly, suddenly I thought, I don't know why it came to my mind. Suddenly I thought, okay, basic derivation is there. Why not try it? See, with the confidence I tried, answer came. Okay, now I will go to next part. Because very simple, so no time waste. Consider next question, question 33, locate centroid. I will tell you what is this one. This actually is cross-section of a pre-stress concrete beam. See, in pre-stress concrete beam, what they do is, beam will be like this. It can be either rectangle or sometime I-section. I'll give you later. Where, in case if it is a post-tension member, before concreting, some duct will be placed there, or during concreting, some hole will be made in the cross-section lengthwise, through which tendons are passed. This all I will cover in pre-stress concrete. But here for you, the question is, locate centroid for the given lamina or given cross-section of a beam, okay, where from a rectangular section, all dimensions in millimeter, I need not tell every time, millimeter, 200 mm by 600 mm, a circular hole of radius 70 mm is cut out at the bottom, and where cut out, the bottom edge of the hole is at 40 mm from soffit or from the bottommost edge, and a rectangular hole of 125 by, how much I took this one? I don't know how much I took, 75, okay. 125 by 75 is cut out at the top edge of which is at 50 from the top edge. Okay, locate centroid. For that's all for you. A rectangle. Okay, now from a rectangle, a rectangular hole and a circular hole are cut out. Okay, start. Note first, axis of symmetry. Understood. See, these offsets are not given. Nobody will provide eccentric. It is a nonsense. Okay, it will create torsion then. Okay, leave it now. So, axis of symmetry, this way not required. If it is 200, 100, 100. How I got 100? You decide. 200 means 100, 100. So, only Y bar required. Divide into three parts. One is a full rectangle, 200 by 600. Full rectangle. And from this one, 2 and 3 are cut out. Cut out. 2 and 2 is rectangle cutout at the top. 3 is circle cutout at the bottom. Make all this note. Now write. Consider reference axis to get Y bar. You should write it all these things. To get Y bar, consider reference line, consider bottom edge, say AB, an axis here or reference line here. From where we will consider Y this way. This is your choice. Y this way. Okay. Draw a neat sketch. 200 by 600. 125 by 75. This is 50 given there. Radius given 70. So diameter is 140. And bottom edge of the circle is at 40 from here. Okay. Now nothing is there. Right. Formula. Y bar from AB equal. Remember now. These two are cut out. This I told you many times. A1, Y1 for full rectangle minus A2, Y2 minus A3, Y3 by total area. Total area is A1 minus A2 minus A3. Now nothing is there. Start. A1, full rectangle, 200 by 600 into, its centroid is here, 600 by 2, minus A2, 125 by 75 into, its centroid is here, 600 minus 50 minus half of 75. Again minus this area, pi by 4 of 140 square into its centroid is here, 40 plus half of 140. Divide by rectangle area, full rectangle area, cut out rectangle area minus circular area. You will get 309.793 millimeter. Okay, over. Right. Therefore, okay, do one thing. So wasting time here only. Here only in mark now. Therefore, right here. Once again, put the sketch if you want. Centroid for the given lamina or cross section of the PSC beam will be as shown below. See, from here, 309. Center of rectangle is how much? 300. So this is 600 total. See, totally 600. 600. Center is here, slightly above. Okay. This is your Y bar. No place to write here. Okay, I'll put shift 600 that side. 600. This is 309 Y bar equal to 309.793 millimeter. If you want to find from top, that will come from total 600, subtract it. From 600 minus 309.793 is 290.207. 290.207. This is the from top. Okay, question is over. Now, those who are serious, or those who want to learn, or those who want to thoroughly practice, gain knowledge, find Y bar from top. I will dictate only. Find Y bar from top. Y this way. Okay. Area 1. Area will remain same. Then, see, A1, A2, A3 will remain same. Y will change. For figure number 1, Y1, 600 by 2. For this one, 50 plus half of 75. For this one, 600 minus 40 minus half of 140. If you calculate from there, it will come 290.207 millimeter. Okay, that is correct answer. Okay, now what I will do is 33 over. Yes, 33 over, correct. 32, 33. Now, I will give few exercises for you. Simple questions. Few exercises for you. Very simple questions. What I will do is, to save the time, I will put the exercise here directly with the answer. I won't calculate in front of you. I will do my own calculation, because I don't have to show everybody that people know about it. So, I will prepare. Oh, I could have rubbed it little late after pausing the video only. I don't know why I am rubbing in front of you. Okay. Okay, two questions for you. Question 34. Last time, see, one rectangle cut at the top, circle cut at the bottom. This time simple. Just a circular part cut out at the bottom. They told directly diameter 180. And instead of giving this distance, they told from bottom edge to center of circle is 150. Or they can give, this is, see, when diameter is 180, this will become 90. So instead of giving 150, if they give 60 here, 60 plus 90, it will again become 150 only. Answer here. Okay, now, full rectangle is 1, cutout is 2. Okay, now, those who want answer. A1, 400 by 750. A2, pi by 4 of 180 square. From bottom if you start, Y1, 750 by 2. Y2, 150. Over. If you do from top, Y1, 750 by 2. Y2, 750 minus 150. You will get answer. Oh, from bottom how much I got? From top I got 354. I note a note there. 395.854. 395.854. It will try to shift that side. One more question. Here, circle is cut out at the top. Diameter 100. Gap is 60. Okay. A1, full rectangle, 250 by 650. Empty circle cut out, pi by 4 of 100 square. If you do from bottom, y1, 650 by 2. y2, 650 minus 60 minus 100 by 2. You will get y bar 314.081. Or if you do y bar from top edge, y1 again 650 by 2, but y2 is 60 plus half of 100. Solve these two questions. I prepared one more small question there. Okay, I'll write it here only. I wrote it somewhere, noted somewhere there. Now, instead of once again pausing and writing, I'll write here only. Little work is there for it. Somewhere, see, sometimes what I do is, if I want some questions, corner I'll make a note. Okay, now, 300 by, 1 minute, there's a, see. Again, question, locate centroid, all in millimeter. I will not waste time on these things, see. 300 by 150, I should maintain scale. 300 by 150, okay. Then it will come down to 125, okay. This is 300. This is, I took, how much I took, because I already solved the question. 150. I already solved and got the answer. This is 125, okay. This is 125. This depth is 500. Bottom is little bigger. How much I took? 250 by 400. Top is 300. Bottom is 400. 400 by 250. I was wondering, 400 by 250. See. Not to scale. This is 500. This is 250. This is 400. If this much given, it is unsymmetrical I section. Already we did earlier. Now, two rectangles are cut. How much? 100 by 90. Where I cut it? I don't remember where I cut the rectangle. 100 by 90. I should have given 110. Yes, because I was wondering where I cut it. 110, correct? Yes, 110, I think most put 110. I don't remember now where I cut it. Okay. 110 is somewhere here. Here, one rectangle cut here. See, one more symmetrically, one more rectangle cut here, out of scale. And this is, how much I told? 100 by 90. This is 100 by 90. This also 100 by 90. This is your lamina, see. Here, this is cut out. To show that what? This is a cut out. Where cut? From here, it is cut at 110. This question. Okay, do one thing. Prepare a neat sketch. Again, as usual. Oh, slightly out of scale. 1 minute. Okay, now correct. Okay, first write. You write one more sketch and write, this is axis of symmetry. Don't waste time. Symmetry. So, X bar is not required. Only Y, right? Only Y bar required. Only Y bar required. Start. Neat sketch. 300 by 150. 125 by 500. And 400 by 250. 250, okay. This is 150. This is 500. This is how much? 250. This is 400. This is 125. This is 300, okay. Now, one rectangle. See, exact position is not given because these details are not required. Symmetry is there. These are, see, this you take figure number 1, take figure number 2, you take figure number 3, full rectangle, this empty portion, figure 4, this empty portion, figure 5. And one of them, put dimensions, how much it is? 100 by 90, enter here. One place enter, sufficient. Don't have to enter everywhere. See, this is 100, this is 90, sufficient. From the edge it is 110. Okay, start. I won't waste time. See, A1, 300 by 150. A2, 125 by 500. A3, 400 by 250. 250. A4 and A5 both are equal. How much? 100 by 90. 100 by 90. 100 by 90. Therefore, your total area equal. Remember, you should write A1 plus A2 plus A3 minus A4 minus A5. 300. I'll check the answer because I want to check the answer. That gap of 110, I got doubt now. I got doubt whether I took 110 up to edge or center. So I will do calculation in front of you once again. That is 300 into 150 plus 125 into 500 plus 400 into 250 minus 100 into 90 into 2. 189500 total area. After A1 plus A2 plus A3, you write in the table form. Minus A4 minus A5 is 189500. Okay, now those people who take y bar from bottom, see, AB reference axis right here. If AB considered for y this way, your y1, y2, y3, y4, y5 will be, see, y1, a total depth you require. Total depth is, I think, 900. It's 900, correct? 250, 150 is 400. 900. I want to calculate now. Y1 equal to, see, centroid here. Centroid here. Oh, this 90 is disturbing me. I will put 90 here. 90 here. Okay. Centroid here. G1, G2, G3 and G4, G5. Y1 will be 900 minus 150 by 2, 825. Y2 will be 250 plus 500 by 2. That is again 500. 500. Y3 is 250 by 2, 125. Y4 and Y5 will be 110 plus 90 by 2. 110 plus 90 by 2 is 155. Both are 155. This will give you, if you do from bottom, this will give y bar, see, this will give you y bar equal to 300 into 150 into 825 plus 125 into 500 into 500 plus 400 into 250 into 125 minus 100 into 90 into 155. Once again, same repeat, equal to divide by 189500. 412 point. Oh yes, I got the same answer there, correct. I got the answer, 412.058. Actually, I got the answer. But later I forgot whether 110 I took up to here or center. So confusion. So I checked once again. Yes, I got that, 412.018. Okay. That means I will show the y bar for you. See, from here to the centroid will be, or I'll come back to this diagram. See, again come back to this diagram. From, if you are doing moment of inertia, later you see, I will enter here only. Why? You have to continue further. But right now, it is only centroid. See, this is 250 plus half of 250 is 500 is 250, 500. You got 412. So it will be somewhere here. Somewhere here. and other is directly here. So this distance and this distance will be 200, 200. Whereas if you want here, both will be 150, 150. Whereas your y bar from where? From here. This y bar I got 412.058 millimeter. If you do from top, you will get 412.058 minus 900, total 900, 487.942. But you draw one more sketch. This is centroid for the beam. Now, just to understand, make a note. Suppose you consider, make a note, reference line through top. Okay, no color, CD. No color this time, CD. Okay, leave AB. And take Y this way. Then your Y1 will be, see, if CD is taken reference, and if you take Y this way, Y1 will be 150 by 2, 75. Y2 will be 150 plus 500 by 2. 50 plus 500 divided by 2 is 400. Y3 will be 900 minus 250 by 2. 775. And your Y4, Y5 will be 900 minus 110 minus 110 minus 90 by 2. 745. 745, 745. Then your Y bar will come. You calculate your Y bar will come 487.942. 487.942. That is, yes, see, from here 487.942 you get this as Y bar. From 900 subtract, you get this distance. Solve the question neatly, enter the answer. Sufficient. Sometimes some people will tell, sir, in some pre-stressed concrete beam, see, they are going to flare it this way. Yes, this question I solved earlier, if you remember. I solved earlier. They will tell, same question, if something are cut out. Okay, same thing, take two more triangles here. Or when I take pre-stressed concrete, I will cover all those things. Now I am not doing pre-stressed concrete. I am only, right now I am in centroid. So centroid part I am covering maximum possible. Okay, now question 34 over, I think 29, I don't remember number now. I think 34 or 35, I don't remember now this question number. See, question number I got confusion. You do one thing. I forward the previous question. You decide question number. Decide question number. If previous question is 33, you make it 34. If previous is actually, if I forgot to change it, you make it 35. Now, maybe another 2 or 3 classes, I will cover it more questions for you. And now onwards, more and more will be exercises. Because why? So much explanation given. Now, you should start working out. Then I will stop and change over to moment of inertia. But I will give at least some more than 50 to 60 exercises in the notes. So those who take the notes there, they will get plenty of extra questions there. But there also, I won't write all the steps. Sometime I will write there. This you enjoy. See, there I can use the words, friendly words I can use, because those people are not known to me. They depend on me for more knowledge. So I can write there, enjoy and calculate. Here also I tell enjoy and calculate. Okay, now we'll meet in the next class. Thank you.